This is Dr. A.M.BALAMURUGAN, Associate Professor, Department of Electronics and Communication Engineering, St. Joseph's College of Engineering. In this second session, we are going to discuss about that scattering parameters representation of the H-plane T. Before this previous session, we discussed about the E-plane T. Now we are going to discuss about the H-plane T. Already I told you in the first session about the introduction of H-plane T. This is also a 3-port network. This is also a 3-port network. This is port 1 and this is port 2 and this is port 3. We are discussing this T microwave passive devices is a power splitters. Okay. Always we are giving the input at port 3. The output will be getting in port 1 and port 2. As I said earlier, whatever the power you are giving, that will be equally divided in port 1 and 2. 50% of the amount, the magnitude will be delivered into port 1 and port 2. And then we proceed with the derivation of the condition that first I will write the condition that which means S13 that it is represents port 3 as input, port 1 as output, which is equal to S23. Port 3 as input, port 2 as output. That means the coupling between port 3 to port 1 and the coupling between port 3 to port 2 are equal. The 50% of the amount will be distributed in the collinear arms. These two are in phase to each other. Whereas in the later one, the H-plane T, E-plane T, that is out of phase to each other, so I use a negative sign here. This is in phase to each other, so I will not use any negative sign. Then according to the symmetry property, the S13 can be written as S31. This S23 can be written as S32. This is called as a symmetry property. This is the condition, this is the property. The condition which states the input which is given feed to the port 3 will be equally divided and delivered in the port 1 and 2, the collinear arms. As well as when you are giving the input at port 3, that is perfectly matched the condition, so which is equal to 0. S33 is equal to 0. Now we are taking the general 3 cross 3 matrix as we did in the previous session, S11, S12, S13, S21, S22, S23, S31, S32, S33. Then what we do first in the sense, we will replace the row 2 and row 3 element with the help of row 1 element for solving purpose. The row 1 will be taken as similar S11, S12, S13. This S21 can be written as S12 because that is available in the row 1. The S22 will be as S22. This S23 can be written as S13. Then S31 can be written as S13. I am replacing the row 2 and row 3 elements as far as the row 1 element. S32 can be written as S23. This S23 can be written as S13. Then S33 is equal to 0. The similar way what we did in the morning, I am writing the equation for the first row. Modulus of S11 squared plus modulus of S12 squared plus modulus of S13 squared is equal to 1 according to the unitary property. The previous session we discussed about the properties, two important properties, the symmetry property and unitary property. The sum of the product of any element in its own rows complex conjugate with the own row is equal to 1. So the 3 values, we are not getting any 3 values, so we will go with the row 3. This is the equation number 1 you consider. Then if you are solving the equation row 3, modulus of S13 squared plus modulus of S13 squared is equal to 1. 2 S13 squared is equal to 1. Modulus of S13 squared is equal to 1 by 2. So S13 is equal to 1 by root 2. Then I got one value out of these 3. Then if you are doing row 1 with row 3, the similar way what we did in the E-plane T, S11 that is row 1 with the row 3 complex conjugate. S11 into S13 complex conjugate. S12 plus S12 into S13 complex conjugate is equal to 0. Then I am moving to the right hand side, S11 into S13 complex conjugate is equal to S12 into S13 complex conjugate. These two are cancelled together. Now your S11 is equal to minus S12, which it means the quantity what you are getting S11 is equal to the minus of S12. Else S12 is equal to minus of S11. We will consider like this. Then if you are using this expression for the equation 1, the equation 1 becomes modulus of S112 squared plus modulus of this S12 I am considering as a S11. Whenever we are taking the modulus, the minus sign will not work out. So S11 squared plus this is 1 by root 2 squared. So 2S11 squared plus 1 by 2 is equal to 1. So 2S11 squared, which is equal to 1 minus 1 by 2, which is 1 by 2. So S11 squared is 1 by 4. Now your S11 is equal to 1 by 2. Your S11 is 1 by 2 in the sense S12 is equal to minus 1 by 2 with respect of S11 minus 1 by 2. Okay. Then we are supposed to find out the value of S2. For this, I am writing the equation for the row 2 with the row 2 complex conjugate. That means S12 squared plus S22 squared plus S13 squared is equal to 1. This is refers the unitary property. Morning I said the previous session that the sum of product of any element in a row with its own rows complex conjugate is equal to always 1. So you know the value of S12. That means 1 by 2 squared plus we are supposed to find out the value of S22 squared. This is 1 by root 2 squared is equal to 1. So which is this is 1 by 4 plus modulus of S22 squared plus 1 by 2 is equal to 1. So what we are taking is modulus of S22 squared is equal to 1 minus 1 by 2 minus 1 by 4. So now your S22 is equal to S22 squared is equal to which is 1 by 4. So S22 is equal to 1 by 2. So now you can replace all these elements with the help of these values. Now your S matrix becomes S11 is equal to 1 by 2, S12 is equal to minus 1 by 2, S13 is equal to 1 by root 2, then S12 is equal to minus 1 by 2, S22 is equal to 1 by 2, then your S13 is equal to 1 by root 2, then S13 is equal to 1 by root 2, this is 1 by root 2, this is 0. This is the S matrix representation of your matrix. Sorry, explain. Again, I will summarize these things. That is, explain these also I am discussing in the power splitter way. Power summer and difference we can find out when you are giving two different inputs in the collinear arms 1 and 2. But I am discussing about this explain T as a power splitter here. This is a 3-port network. Port 3, as always, I am referring as the input. Port 1 and 2 will be the output. Whatever the input you are giving in port 3 will be equally divided with the collinear arms. The coupling between port 3 to port 1 and the coupling between port 3 to port 2 will always remain same in magnitude level. And moreover, in this explain the phase difference are in phase between the coupling between port 3 to port 1 and port 3 to port 2. So, I am writing a equation condition for this explain D, that means the amount which is coupling from port 3 to port 1 and then the amount coupling from port 3 to port 2 will always remains the same. Then according to symmetry property, this S13 can be written as S31, this S23 can be written as S32. Always whenever you are giving the input at any port, we are referring that the port will be perfectly matched. So S33 will be is equal to 0. The similar way, how I am finding that properties, using the property to find out the S matrix representation of the E plane D, the similar way I proceed. So finally I will get the value S matrix of the H plane T. That's all. Next we will discuss about that magic T, which having a E plane T and H plane T in the same device. That is a 4-port device. That is a 4-port device. We will see how the magic T working and how we derive the S matrix of the magic T. The magic T is a 4-port network. Now we will see that is a 4-port network. That is for the representation. I am using the one as the sliding one. Sliding rotation. For our convenience, we will refer like this. This is port 1 and this is port 2 and this is port 3. This is E plane T input. This is always this E plane T input. This is port 4. This is for H plane. At a time you can realize only one T by using this magic T. But the device can be operated as a E plane as well as H plane. Then port 3 is always the input port. Port 4 is also a input port. Port 1 and 2 will be always as the output port. Always the output ports. It's a combination of E plane and H plane in the same device. It's a 4-port network. For that, first we have to write the condition, and using the symmetry property we have to enhance the condition. Hope you can understand. That is, the 4 ports are available. Port 1 and 2 will be the output port. Port 3 is for the E plane T input. Port 4 is for the H plane T input. Now we will see. First we will write the expression for the E plane. So it is similar to that the E plane T what we derived in the previous session. That means S13 is equal to minus S23. 3 what we are giving the input, which is coupled with the port 1 and which is coupled with port 2 will be magnitude will same, but it is two of the out of phase to each other. So the minus sign represents the out of phase. Now here you see the SM3 is equal to, according to the symmetry property, you can extend this as S31. This minus S23 can be written as minus S32. This is the condition. This is the property, symmetry property. Symmetry property for the reciprocal devices. What we can write as Sij is equal to Sji when I is not equal to j. In the similar manner, if you are writing for the H plane T, writing for the H plane T in the sense S14. That means what I am giving the input at port 4, coupling with port 1, which will be equal to S24. 4 is the input, 2 is the output. The coupling between the port 4 to port 1 is equal to the coupling between port 4 to port 2. So according to the symmetry property, I can elaborate this as S41. The S14 can be written as S41 and this can be written as S42. S42. Apart from that, we are giving input at port 3 and port 4, not at the same time, but we are always using port 3 as the input port for the E plane T, port 4 for the input port for the H plane. So I am writing, it's a perfectly matched distance. S33 is equal to S44 is equal to 0. S33 and S44 is equal to 0. In the similar way, there is no coupling between these two input ports, which means port 3 and port 4. So S34, S43 is equal to 0. What it refers in the sense, we never give any input at port 3 and we will never try to measure any output quantity at port 4. The similar way, we are never given any input at port 4 and try to observe anything at the port 3. These two are completely input ports. That's the meaning of this. Apart from that, you can write an expression that there is no coupling between output ports, which refers S12 and S21 is equal to 0. there is no coupling between the output ports. How I am saying that the input coupling between the input port and the coupling between the output ports will always be 0. Now we frame the 4 cross 4 matrix, and for our solving purpose we will replace the row 2, row 3, row 4 elements by using row 1 element. Okay, first we will write the 4 cross 4 matrix S11, S12. This is the general S matrix S14, S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, S44. Okay, already I told you, for our solving purpose we have taken the first row as it is like S11, S12, S13, S14. I am trying to replace these things by using the row 1 element. This S21 can be written as S12 according to the symmetry property. The S22, similar way S22. This S23 can be written as minus S13. Can be written as minus S13. Then this S24. This S24 can be written as S14. Then this S31. This S31 can be written as S13. S31 can be written as S13. This S32 can be written as S minus S13. Then this S33 is equal to 0. S34 is equal to 0. The similar way S41. S33 is equal to 0. This is that there is no coupling. This is perfectly matched. We are using this port as the input port for the E plane T, so which will be equal to 0. This S34 is equal to 0. How we are writing this? S34 is equal to 0. That means there is no coupling between the input ports and all actually. Always we are using the port 3 as the input port and port 4 is the input port for the H plane T. This S41. This S41 can be written as S14. Then S42. This S43 can be written as S24, but this is not available in the row 1, so it can be replaced as S14. Then S43. S43 is equal to 0. Your S44 is equal to 0 because I am using the port 4 for the input port for the H plane T. So now you have to solve this expressions, the matrix value. Then I start with the row 3 and row 4. Row 3, modulus of S13 squared plus modulus of S13 squared is equal to 1, which means this is a unitary property. Any element in a row is multiplied with its own complex conjugate, which is always equal to 1. So from this is 2 S13 squared is equal to 1, which means S13 is equal to S13 squared is equal to 1 by 2, which is S13 is equal to 1 by root 2. So I found out one value. Next I am using the row 4 to find out the value of S14. The similar way I can write this S14 squared plus S14 squared is equal to 1, which means your S14 is equal to 1 by root 2. I found out 2 values so far. Okay. If I know 2 values, then I can solve any equation, but I need to know one more value. So for that what I am doing is row 1 with the row 3 complex conjugate. Row 1 with the row 3 complex conjugate. Row 1 with the row 3 complex conjugate, which is S11 into S14 complex conjugate, then S12 into plus S12 into S14 complex conjugate is equal to, that is equal to, these two values will become 0. So this is equal to 0 because I am taking two different rows of the element. Row 1 with the row 3 row 1, row 3 complex conjugate. This is S13. S13, and this is also minus S13 complex conjugate. Either you can do with row 4, I am doing with row 3. So this is S11 into S13 complex conjugate, which is equal to S12 into S13 complex conjugate. So these two are equal. Now it refers S11 is equal to S12. So hereafter you can replace this S11 as S12 or S12 as So I know the value of S13 and S14. So I can try to find out the value of S11 and S12 from the equation number 1 by using that row 1. That means modulus of S11 squared plus I am considering this S12 as S11. Either you can replace this S11 as S12 or this S12 as S11. So S11 squared plus S13 is equal to 1 by root 2 squared. And straight away I am writing this is 1 by 2 plus this S14 is equal to 1 by root 2. 1 by root 2 the whole squared is equal to 1 by 2, which is equal to 1, and because I am doing that row with the same row complex quantity values. So now it is 2 S11 squared, which is equal to 1 minus 1. This 2 half will move it to the right hand side, which becomes 0. So always S11 is equal to 0. If S11 is equal to 0, S12 is also 0 because of this expression. Whatever the value of S11 which is equal to S12. So if S11 is 0 in the sense, S12 is also 0. Next, we need to find out the value of S22. So I am framing the equation for the row 2. That means row 2 with row 2 one complex conjugate. Row 2 I am forming, that is S12 square, modulus of S12 square plus modulus of S22 square plus modulus of S13 square plus modulus of S14 square is equal to 1 because I am doing that same thing for the same row. So this is S12 which is 0 plus S22, that is the value I need to find out. Then value of S13 squared is 1 by 2 because this is 1 by root 2. 1 by root 2 the whole squared is equal to 1 by 2 plus similar way S14 is also I found out that the value was 1 by root 2. So 1 by root 2 squared is equal to 1 by 2, which is equal to 1. So modulus of S22 squared is equal to 1 minus half, which is equal to 0. So from this I conclude this S22 becomes 0. The value of S22 is 0. So hope I found out all the values of this matrix. So now I can frame the S matrix of the 4-port network magic. This is magic. So S11 is S matrix will be represented as, okay, S11 is equal to 0, S12 is equal to 0, S13 is equal to 1 by root 2, S14 is equal to 1 by root 2. The similar manner in the second row, S12 is equal to 0, S22 is equal to 0, and this is minus 1 by root 2, this is because this is minus S13, S14 is equal to 1 by root 2. Then S13 is equal to 1 by root 2, this is minus S13, this is minus 1 by root 2, then these values is always 0. S14 is equal to 1 by root 2. This is also S14. This is 1 by root 2. This is 0 and 0. This is the S matrix representation of the magic T. Hope you all understand that the concept of the magic T, how it is working and how we can derive the S matrix representation of the magic T. Again, I will go through one more time. In some of the books, textbooks, they will refer like this. They will take the 1 by root 2 as outside, so they will represent like this. S matrix is equal to 1 by root 2. They will write 0, 0, 1, 1, 0, 0, minus 1, 1, then 1, minus 1, 0, 0, 1, 1, 0, 0. Both are same. They are taking 1 by root 2 as common and taking outside, they will represent like this. Both are in a similar format. Now I conclude how this explain T is working. The explain T is also a 4-port network. These two are the output ports, always 1 and 2. Port 3 as the input port for the E plane. Port 4 as the input port for the H plane. That is the combination of E plane T and H plane T. That is most important, that how we frame this conditions and symmetry property applicable for this device is most important. First, we are writing for the E plane the condition. That means the coupling between port 3 to port 1, port 3 to port 2 will be, the magnitude will be equally divided. Then these two are out of phase to each other. The negative sign indicates the These two are the out of phase to each other. Similar way, I am writing the condition for the H plane T, because port 4 here is the input port for the H plane T. Whatever the amount of input we are giving in port 4 will be coupled with port 1, will be equal with the coupling between the port 4 to port 2. These two are in phase to each other, so there is no negative sign here. In the previous session, I explained about the symmetry property for the reciprocal devices. These are all the reciprocal devices. The meaning of the reciprocal devices also I clearly explained in the morning session, the previous session, that is, whose forward characteristics is equal to the reverse characteristics is called as the reciprocal devices. Now in this time you can raise a question that can you tell me there are some examples of the non-reciprocal devices, in the sense that isolator, circulator, these are the non-reciprocal devices. It has some ferrite pieces, ferrite rod in this devices. It produces the non-reciprocal property whose forward characteristics is not equal to the reverse characteristics. These are the reciprocal devices. In the previous session what we discussed, E plane, the H plane, the magic T, all these are the reciprocal devices. So the condition will be applicable, that it is called as a symmetry property, which means your Sij is equal to Sji when I is not equal to j. So I can write this S13 can be equal to S31. This S23 can be written as minus S32, because this is minus, I am writing minus S32. The similar way S14 can be written as S41, this S24 can be S42. And these conditions, what I am referring is, I am giving input at port 3 for E plane and port 4 for the H plane. So always where I am giving the input, I am considering the port is perfectly matched, so which is equal to 0. These are the expressions, the inference what I arrived is, the port 3 and port 4 is purely used for the input ports. There is no coupling between the input ports. You cannot give any input at port 3 and then you try to measure anything from the port 4. In the similar way, vice versa. These two, always there is no coupling between the S34 and S43. In the similar way, the port 1 and 2 will be always using for the output ports. We are not giving any input in port 1 and referring any output at port 2. There is no coupling between the output ports. So I am writing S12 is equal to S21 is equal to 0 for my simplification process. This is the way what I did in the E plane T, H plane T, the same way. I am writing the general 4x4 matrix because this is a 4-port network. I am writing the first expression. First row is exactly as the first row. The row 2, row 3, row 4 rows I am trying to replace. For my better way to easily calculate the all, instead of calculating all 12 elements, for simplification process I am replacing the row 2 and row 3 and row 4 element with the help of row 1 element. Using the symmetry property, most of the elements I can replace by using the row 1 except S22, because this I and j values are similar, this condition will not work out here. Then I am finding that S13 and S14 straight away. I am solving this and I am getting 1 by root 2 and 1 by root 2. Then after that I am substituting these values. If suppose you need one more value, in the sense I am using the row 1 with the row 3 complex conjugate. From that I observed that the value of S11, the magnitude of the S11 will be similar to that, equal to S12. With reference to S12, S11 is equal. S12 with reference S12 will be equal. So S11 and S12 will be equal. So instead of in places S11, we can replace S12, or in the place of S12, you can replace S11. From that, the ideology, I solve the first row by using S11. I am getting S11 value is equal to 0. So if it is S11 is 0, automatically the S12 is 0. In a similar way, I am trying to solve the second row and find out the S matrix of the magic T. This is a 4x4 network. I am finding the S matrix of the magic T. Thank you for all you listening this lecture. If it is available in any portal, then you can comment. If you have any doubt, you can ask me through the comment box. Then I will post that PDF, the written document of the magic T, H plane T and the E plane T.